Physics channel. I'm Steve, and today we're going to be doing a projectile motion problem. In this question, you're shooting a bow and arrow at a target, and the starting height and the ending height of the arrow are the same. So right where you're releasing the shot and where the bullseye is are the same height. We want to know if the initial velocity can only be 75 meters per second with this bow. What is the angle that you should shoot it at so that you hit the target that's 100 meters away? Go ahead and pause the video. When you're ready, I'll show you how I did it. Welcome back. First things I always like to do is I like to write all the things that I know off to the side. So in this case, we know that the initial velocity has to be 75 meters per second. However, we don't know either the x or the y component of it. And we know that the range has to be 100 meters. And we know that we're on Earth, which the gravity is 9.8 meters per second squared. However, we also do not know the angle at which the shot is fired at. That's what we're trying to find. Now, to do this, we need to use an equation that we don't normally use, a range equation. However, because it's not a normal equation, we don't necessarily know it off the top of our head, so we're going to have to develop it. And to do that, we need to first start with what is the initial velocity in the y direction. So that's just simply the initial velocity times the sine of theta, which we don't know. And then we also know the general equation that height is equal to the initial velocity in the y direction plus 1/2 times gravity times time squared. So then when we plug everything in, we have the equation height is equal to the initial velocity sine of theta times time plus 1/2 times gravity times time squared. Now, when we want to solve for this equation at the two times, when the first time being when you first release the arrow, and the second time right when it hits the bullseye, because we know that those are at the exact same height. So the height of equal to 0. And when we plug that in and solve for time, we get this rather complicated looking equation. However, you can use the quadratic equation to solve for t, and we get the possible answers of t is equal to 0 or t is equal to 2 times the initial velocity sine of theta all divided by g. Then all I have to do is plug that into the distance equation, or in this case, the range equation, which is the initial velocity in the horizontal direction times time. And when we multiply those two things together, we get a rather nasty looking problem that has both sines and cosines in it. However, if you rearrange the equation, initial velocity squared divided by gravity, and then in parentheses you have cosine theta times 2 sine theta, which, if you know your Pythagorean identities quite well, you'll know that that is a double angle identity, which we can then replace with sine of 2 theta. And then when we do that, we get that the range is equal to the initial velocity squared divided by gravity, all times the sine of 2 theta. Which we now have a very easily solvable equation, and we know all of the variables except for theta. We plug in everything we know, do a little algebra, and we find that the angle of the shot has to be 5.02 degrees above the horizontal. Hopefully that wasn't too bad. If you do have questions, please leave them down in the comments below. And if this video helped you, please like and subscribe for more content just like it. And until next time, have a great day.